Here we have a geometry problem. Okay, let's go to the question. There is a figure given over here. In the figure above, find theta. That is, we have to find the angle measure theta we have over here. Okay, let's plan how to find the angle measure theta over here. So for that, we have to consider the quadrilateral BCDP over here. In this quadrilateral, so if I know the three interior angle measures, the interior angle measure over here, the interior angle measure over here, and the interior angle measure over here. If I know the measures of these three interior angles, I'll be able to find the interior angle measure over here. So once I get the interior angle measure over here, I can use the angle on the straight line to get the angle measure theta. So now our aim is to find the three interior angle measure over here, here and here. Okay, now first let me find the interior angle measure we have at the center of the circle. Okay, so this is the angle subtended by the arc BD. So the arc BD subtends this angle at the center. And already we know that the angle subtended by an arc at the center of the circle is twice the angle subtended by the same arc at a point on the circle. And we know that this is the angle subtended by the arc BD at a point A on the circle. Then what is the measure of the angle subtended by the arc BD at the center? So it is twice the angle subtended by the same arc at a point on the circle. So 2 times of this 64 degrees, 128 degree. Okay, now I got one of the interior angles of the quadrilateral BCDP. Okay, now let's consider this BC and this DC. Both of them are radius to the circle. Okay, and also PE is the tangent to the circle from the external point P. And also B is the point of tangency. That is, B is the point at where the tangent P touches a circle. So whenever I draw a tangent to the circle from an external point, at the point of tangency, the angle between the radius of the circle and the tangent will be 90 degree. That is, the radius and the tangent will intersect at right angle at the point of tangency. So the same thing we have over here at D, because PG is a tangent to the circle drawn from the external point P, and the point of tangency is D. At the point of tangency, the angle between the radius of the circle CD and the tangent has to be right angle, that is 90 degree angle measure. Okay, now I got the measures of the three interior angles of the quadrilateral. So using these three interior angles, I can find the interior angle measure over here. Let me assume this Y represents the interior angle over here. Okay, now if I add the four interior angles of a quadrilateral, it must be equal to 360 degree. In any quadrilateral, the four interior angles will add up to 360 degree. So let me add them. That is 90 degree, positive 128 degree, positive 90 degree, positive Y equals to 360 degree. So in quadrilateral BCDP. Okay, now when I add 90, 128 and 90, I am getting 308 degree, positive Y equals to 360 degree. Okay, now to solve for Y, I have to subtract 308 degree from both sides. So let me do it. So when I do so, this positive 308, negative 308 will cancel out. I'm getting Y on the left side. On the right side, when I subtract 308 from 360, I'm getting 52 degree. So now I got the measure of the fourth interior angle of the quadrilateral Y, that is 52 degree. So we can replace this Y by 52 degree. Okay, already we know that this is a straight angle because this is the angle on the straight line EF. So already we know that always the straight angle measures 180 degree. So in this straight angle 180 degree, this part is 52. What is the measure of this part? So that is this theta and this 52 degree together form a straight angle. So these two angle measures theta and 52 degree must add up to 180 degree. So let me write this one as an equation. Theta positive 52 degree equals to 180 degree, the measure of the straight angle. So my aim is to solve for theta. So for that I have to subtract 52 from both sides. When I do so, this positive 52, negative 52 will cancel out. Then theta is equal to, when I subtract 52 from 180, I am getting 128 degree. So I got the angle measure theta, that is equal to 128 degrees.